This is the second volume in our Practical Tricks series on Y vector search engine. Today, we're focusing on a really interesting challenge, tracking down a film or anime when all you have is a fragment of the plot stuck in your mind. You know, that feeling when, emphasis, the title is just on the tip of your tongue. Unlike traditional search engines like Google that look for exact words, vector search digs deeper to understand the meaning and the why behind your query. This approach makes it much easier to find what you're looking for, even when your memory is fuzzy. This vector search engine is protected by a granted Japanese patent, number 7,859,641. What sets it apart are three key features. First, it searches by meaning, not by matching individual words. Emphasis, so even if there are 0 shared keywords, it can still find results with a closely aligned intent. Second, it focuses on the why, it isolates the motive or feeling behind the text before making a match. And third, it provides transparency by explaining each result with a similarity score and the reasoning behind it. For example, if you search for something warm to wear, it might return down jacket, even though none of the words match exactly, because the meaning aligns perfectly. Here, we're dealing with the challenge of finding a film just from a small fragment of memory. The only data you need to prepare is a single text file called input.txt. This file contains 12 movie titles, each paired with a brief fragment that people commonly remember about that film. For example, one fragment might describe the plot of Eternal Sunshine of the Spotless Mind, focusing on the theme of memory erasure, while another describes Spirited Away, recalling the iconic red bridge and bathhouse. Importantly, no dialogue is included, everything is written in your own words to avoid copyright issues. You can use any format, as long as the file includes just a heading with the title and a simple description. This straightforward approach is the foundation for how we use the vector search engine in this case. Here are just 3 simple steps to get started. Emphasis, step 1 is to extract the why, pull out only the reason a work stays in memory. You do this with the command cargo run why. Break, step 2 is to vectorize, which means turning these words into coordinates, essentially a row of numbers, using cargo run vec. Finally, step 3 is to search by finding the closest title to your query and explaining why, done with cargo run query. The key point here is that the code itself never changes depending on the subject, just swap out your input file, and you can search songs, films, or anything else you want. Here in main.rs, we have what I like to call the receptionist. Its job is simple but crucial, it directs traffic. When the program starts, it reads the command argument and then routes to one of 3 tasks. If the argument is why, it goes to the extractor. If it's vec, it handles vectorizing, and query sends it to the search function. This part of the code is intentionally simple, emphasis, nothing complex happens here, just straightforward routing. Now let's look at the code walkthrough for y_extract.rs. This part specializes in pulling out only the emphasis, why, the underlying motive or feeling behind the text. It reads the input file, then asks GPT-4 to extract just the why from the text. From each synopsis, it focuses on what makes the work memorable, like, a name is forgotten, or, a memory erased. That why is the key element here. Finally, the extracted information is saved into a JSON file with a unique UUID for use in the next step. Here, we dive into the heart of the process with the code walkthrough of vectorize_y.rs. This is where the magic happens, turning words into map coordinates. You start by creating a payload with the target text and specifying the embedding model, in this case, text embedding 3 large. Then, a request is sent to the API, which returns the vector representation. Emphasis, this means words like wistful and aches in the chest become neighbors on this map, reflecting their closeness in meaning. Break, the closer their meanings, the closer their coordinates are placed. Finally, all these title coordinates are saved into vector.json, so everything's ready for the next steps in the vector search process. Here we dive into the code walkthrough for query_y.rs. The core idea is that the question itself is converted into a vector, turning it into coordinates. Then, we measure the distance between these vectors using cosine similarity. Emphasis, the record with the closest vector, the highest similarity, becomes the answer, even if it doesn't share any words with the question. What really stands out here is that after finding this closest title, GPT-4o steps in to explain why it made that choice. This explanation capability is the highlight of the patent, showcasing how the AI not only finds answers but also clarifies its reasoning. Here's the live test. Can it really find the right film from just a fragment? The query is about a movie where a man has a former partner's memory erased, and he tries to hide her during the process. Notice, we didn't provide any title, director, or cast information, just the plot fragment. The vector search engine returns, emphasis, eternal sunshine of the spotless mind, with a similarity score of 0.89. This high score shows how well the system understands the plot details, mapping your description closely to the movie's storyline about memory erasure and the emotional struggle involved. This practical example really highlights the power and accuracy of vector search technology. Here, we're deliberately looking for something that isn't in the corpus at all, a film about fighting insect-like creatures aboard a spacecraft. Notice that every score we get back is around, emphasis, 0.3, which is clearly low. This low score signals a no match. As a quick guide, scores above 0.7 are reliable, between 0.5 and 0.7 mean you should double-check, and anything below 0.5 means no match. This scoring system is crucial because it tells us when the search has missed, unlike some AI that might just provide a plausible but incorrect answer. All the code we've discussed today is available on GitHub at this link. To run the same experiment, you'll need a Rust toolchain, specifically Cargo, and an OpenAI API key. The great thing is, you don't have to change any code, just swap out the input.txt file for any genre you're interested in. Then, simply run the 3 commands in order to get started. This makes it really easy to experiment and see the results for yourself. Thank you for watching. Next up, in Volume 3, we'll dive into searching your own notes, that moment when you know you wrote something down, but just can't remember where. If you found this useful, please subscribe and hit like so you don't miss the rest of the series. You can also find the source code on our GitHub, check out the related book on Amazon Kindle, or explore the ready-to-run AMI available through AWS Marketplace. Thanks again from Urata Soft, and see you next time.